partial fraction. And class, there are three classes of partial fraction. One, we have partial fraction with linear factors. Partial fraction with linear factors. Class, no noise. Partial fractions with linear factors. Class, first of all, what is a partial fraction? In order to understand partial fraction, you must understand your normal fraction. Class, if I give you a fraction like this, 2/4, this is a normal fraction. Right? We all are aware of fraction, right? Every fraction has numerator and denominator, right? Now, every fraction has numerator and denominator. Class, every fraction can be decomposed into component fractions. And those component fractions are what we call the partial fraction of that particular fraction. Class, are you aware that 2/4 can still be written as 1/4 plus 1/4? Are you aware that if you add up 1/4 plus 1/4, you're going to have 2/4? If these two fractions can be added up to give this fraction, then these two fractions are said to be partial fractions of this fraction. Then these two fractions are said to be what? Partial fractions of this particular. So class, in this topic, you'll be given some fractions, but this time around it will not be a normal fraction. It will be fractions that have x variables. Fractions that contain polynomials, linear, quadratic, as the case may be. And you'll be asked to decompose them into their component fraction. Class, for example, are you aware that this is also a fraction 2 into bracket x plus 2, x minus 1? This is also a fraction, class. Any mathematical expression that has a numerator and a denominator can be called a fraction. And class, are you aware that just like 2/4 can produce two partial fractions, 1/4 and 1/4? Are you aware that this fraction can also produce two partial fractions? And in the exam, you could be asked to decompose this particular fraction into two partial fractions. Now, this particular partial fraction I just wrote on the board now is called a partial fraction with linear. Why do we say this is a partial fraction with linear factors? Class, take a look at the denominators. Look at the power of x in the denominator. Are you seeing that is 1? X means x raised to power 1, right? X means x raised to power what? So this kind of partial fraction is a partial fraction with linear factors because the denominators, the factors present in the denominators are what? Are linear. They are what? Linear. Class, we can also have what we call partial fraction B. Partial fraction. Remember we said we have three classes of partial fraction, right? Partial fraction with repeated factor. With what? Repeated factors. Class, in this scenario, let's give an example of this. Class, this same fraction, we're going to write it 2 all over x plus 2 and x minus 1 all squared. Class, this is a partial fraction with just linear factor, but this is a partial fraction with repeated factors, or you could say repeated linear. You can say repeated linear, or sometimes even quadratic factors. Repeated linear or what? Quadratic factors. Because sometimes these factors will not only be linear, they will be called quadratic. I'll come to that. Class, the rule you use in resolving this type of fraction is going to be different from how you resolve this one. Class, how do you resolve partial fraction with linear factors? 2 all over x plus 2 and x minus 1. Class, in this kind of partial fraction, we are going to say, so it is clear, class. Let me tell you something, class. How can we know the number of fractions that this particular fraction contains. Because partial fraction means the smaller fractions that can be added up to give a main fraction, right? So if you have to decompose this fraction into its partial fractions, the question you should ask yourself is, how many partial fractions can this fraction produce? Class, this fraction can produce 2 partial fractions. And let me tell you why. It can produce 2 partial fractions because we have 2 denominators. 2 what? Class, the number of denominators can usually help us know the number of partial fraction a fraction can produce. So class, this partial fraction can produce 2, this fraction can produce 2 partial fractions. And class, we're going to call the first fraction A and the second fraction what? B. And as usual, every fraction must have a denominator, right? You can't be a fraction without a denominator. So class, this A, let the denominator of this A be this first denominator, x plus. And let the denominator of this B be this second denominator, x minus 1. I'll come again one more time, class. We are given this fraction, right? And we have to decompose this fraction into its partial fractions. First thing you need to ask yourself is this. How many denominators do I have? How many what? Class, I have 2 denominators, 2 factors, x plus 2 and x minus 1. And the 2 factors are linear. That's why we call this fraction partial fraction with linear. Why do we say they are linear? The power of x is what? 1. Power of x is what? As you can see here. So they are linear factors. How do you decompose this fraction into partial fraction? The understanding of this will help you understand that question they gave in your workbook. Class, first things first, you are sure that this fraction can be broken down into 2 partial fractions, right? How do we know there are 2? Because we have 2 denominators. Class, call the first fraction A, call the second fraction what? Now, you now say A all over first denominator x plus 2 plus B all over what? Second denominator x minus 1. Class, the beauty of partial fraction is that after getting the 2 fractions, you can test if you are correct or wrong. You can add up these 2 fractions back and find out, will it give me my question back? If it gives you your question back, then you know that the 2 partial fractions you got are correct, right? I started this class by saying 2 over 4 is a fraction, and it can be broken down into 1 over 4 plus 1 over. If these 2 guys are correct, if I add them up, it should give me 2 over 4 back, right? Let's do it. If you say LCM will be 4. 4 divided by 4 is 1. 1 times 1 is 1. Plus 4 divided by 4 is 1. 1 times 1 is 1 plus 1 is what? 2 all over 4. So you can never go wrong in partial fraction except you want to go wrong, class. Because after getting your partial fraction, you can test your answer, am I correct? Add them back together and see, will it give me back my question to know if you are correct or wrong. So class, we are here now. After getting the 2 partial fractions, class, in most cases, to get the partial fraction, you will usually know the denominator. It is the numerator that is usually the unknown that we don't know. The denominator is usually what? Known. Because the denominator is usually gotten from the question. So it's the numerator we don't know. So we'll call this guy's numerator A and call numerator what? B. We're not going to find the LC, we're going to find the LC. Class, LCM must be x plus 2 into bracket x minus 1. What do we have on the right hand, on the left hand side here? 2 all over what? X plus 2, x minus 1. So let's resolve this now. Class, x plus 2, x minus 1 divided by x plus 2. What happens? X plus 2 cancels x plus 2, right? We are left with x minus times a. You have a into bracket x minus 1. Plus x plus 2x minus 1 divided by x minus 1. X minus 1 cancels x minus. You're left with b into bracket x plus. Class, there's a shortcut approach you can use here. Anytime you just have 2 denominators like this, you can say a open bracket x minus 1, cross it, plus b open bracket x plus. You don't need to stress yourself doing this. Now class, when you find out that, look at our left hand side and our right hand side, you will notice something. Our denominators are the same. S plus 2, s minus 1, s plus 2, s minus. So they can cancel out. They can do what? So that we can now focus on only what is on top. So what is on top is now 2 equals to a into bracket x minus 1 plus b into bracket what? Class, once we can get a and b, we have gotten our partial fraction. Right? Because a fraction is made up of 2 parts, numerator and denominator. We already have denominators here. Denominators is these numerators we are looking for. How can we now get a and b from this equation? We have 2 unknowns in only one equation. Plus, there are 2 methods. There are 2 methods. Class, for this kind of simple partial fraction, see what we can do. First of all, let's expand the bracket. Let's expand if we expand this bracket, please let's continue here. If we expand this bracket, we're going to say 2 will be equal to a times x. A times minus 1 minus a. Minus what? Plus b times x. Bx. And b times plus 2. Plus 2b. Plus 2 what? We're going to say 2 will now be equal to ax. Let's call it like this. Plus b minus a plus 2b. Class, it's almost time to do something we're going to do here. Class, notice on the left hand side we have only 2. But on the right hand side we have components that are carrying x and components that are not carrying x. Class, but on this side we only have components that are not carrying x. We don't have a representative of the component that is carrying x on the left hand side. So we're going to introduce it by saying 0x. We're going to say 0x plus 2 equals to ax, please follow carefully, plus bx minus a plus 2b. Now see what we're going to do, class. Why did I introduce 0x here? Because I want to equate elements that have x here to elements that have x here, and equate elements that do not have x here to elements that do not have x here. And I'm going to form 2 equations. So I'm going to have ax plus bx equals to 0, and I'm going to have minus a plus 2b equals to 2. Equals to what? 2. Class, ax plus bx equals to 0. If we divide all through by x, what will happen? X cancels x, x cancels x, x cancels. What will be left? This implies that a plus b equals to 0. If a plus b equals to 0, does it mean that plus b can move to this side and become a equals to minus b? So a equals to minus b, class. Are we correct? Now from equation 2, minus a plus 2b equals to 2, right? But from equation 1, class, a is minus b. Means anywhere we see a, we can put minus b. Am I correct? Let me replace this a with minus b. What will I have? Minus into bracket minus b plus 2 equals to minus times minus plus. So we have plus b plus 2 equals to b plus 2b, class. 3b equals to 2. Can we divide both sides by 3? So that b is what? B is 2 over. Class, if b is 2 over 3 and a is minus b, what must be a? A is minus 2 over. So b is 2 over 3 and a is minus 2 over what? You say? The extra? B is just 2 over 3. So by the time you say a equals to minus b, so minus 2 over 3. Now, class, we've gotten a and b. It's now time to put it into our fraction. Remember that this is our fraction, right? These are the 2 partial fractions. So how do we impute a as what? Minus 2 over 3. You say minus 2 all over 3. Class, bring the 3 down. Into bracket x plus 2. Into bracket what? X plus. A is minus 2 over 3. And b is what? B is 2 over what? So you say 2 all over 3 into bracket x minus 1. And class, these are the 2 partial fractions that makes up this particular fraction. These are the 2 partial fractions that makes up this particular fraction. Are we together, class? Now, we'll come again with this next one and you see it step by step. Now, class, stop this one.